Oh, hi everyone. I'm Kuo, and so this semester we are doing a Alzheimer disease prediction using a big data solution and LLM. Next, please. And this is a table of our context, and next, please. So I want to quick introduce our project. So our project is actually create a new idea that we want to investigate an application of multi-agent large language model to pre-process the natural language and detect the Alzheimer disease. So our challenge on the data is our data set is really large. It's hard to clean and analyze. So 20 gigabytes is over 200 more thousand rows. So they're full of the vague description, medical terminology, and foreign language. So in our method, we build a classification model, so which predict discrete CDR. CDR is our label data, and from four columns natural language, we call SOAP. It's a four-column input column. And for our system is we build a front-end website, so user can without any CS background can easily to upload a BCS field and get notice with Alzheimer's disease and a high-risk keyword graph. So next, please. So in our data set is our data type is a semi-structured data. We each have natural language and also a number. So in each row, the data also have medical terminology and also Chinese medical terminology. So there are a lot of work for translation. And for SOP, it's a subjective objective assessment plan. So it is like a standard for medical data. And the third one, data resources is 10-year private data collected by Taiwan Hospital, is Alzheimer's disease department. So for data size, 20 gigabyte big electrical health data. So next, please.
This is like the high level overview of our data pre-processing pipeline. We store the data in Google Cloud, and so we write program to programmatically fetch the data. And other tools we use are Spark and Airflow. Are the data processing tool we use. Spark we used to handle the duplicate data and the missing values. And for the translation from Chinese to English, we use a LLM agent along with Airflow to do the translation and the cleaning. Next slide, please. As you can see, this is the high-level chart of our pipeline where the data is stored in GCP. We fetch it, Spark, we pre-process it using Spark and Airflow. And finally, we feed the data into various models to do the predictions. Next slide, please.
So I want to introduce our how we do the translation work. So I think this is our key challenge, technical challenge in our project. We can see the example is in the first, this is a one input row. So we can see that first they will have a label data in the input column, which is CDR. So the first thing we do is we just claim the label data from the original input row. This is the first thing we do to pre-process. The second one is they have a lot of Chinese. So how can we translate Chinese? Because some Chinese have a lot of some medical terminologies, and it's very hard to translate. So we read a prompt skill to tell the large language model to know he's translate a medical Chinese data. So if we tell him what he gonna do, he will have a high accuracy for in a translation. So in the cleaning data airflow, we use airflow to help us to pre-process data to manage our workflow of pre-process. So for the block diagram, we can see that the raw input data, which have a CDR label data and also a lot of Chinese. So we first put on a masking using a Spark. So the Spark will help us to clean the CDR data and to do a masking. Second one, he sent to the large language translation agent. So that agent will help us to translate, to understand the Chinese, and after that translate to the English and to allow the whole sentence to make sense in English. After that, he will output a clean input training data. So we'll use that training data to train our model. so which can improve higher accuracy of our prediction. So next, please.
So I will introduce the method or the models we will use. First, traditional machine learning models like the SVM, MLP, or recursive neural networks, they are noise sensitive and rely on expert experience, so they may not be suitable for our case. So what is noise sensitive? In our data, there are lots of Chinese characters within each sentences, and these are not the uh, and these Chinese characters often serve as a noise to the other useful information that written in English. So these traditional machine learning models may not be able to analyze well accurately or generate high accuracy. And these models often also these models often relies on some methods like knowledge graph, keyword extraction, and semantic analysis. They rely on human expert experience. However, pre-trained large language models have rich related experience and make it very cheap and efficient to analyze these semi-structured and unclean natural language data. Also, for the large language models, we can just feed everything to them, and we can further use multi-agent models, RAGs, and chatbot data cleaning to further improve the performance. So our model will be very easy to use for medical workers and ordinary people without any computer science background. So for the first large language models we use is BERT. This is a pre-trained bidirectional language model and only contains transformer encoder architecture. They are good at understand the tasks. In other words, they are good at classification and annotation tasks. So BioBERT is a variant of the BERT model that pre-trained on more medical articles. So the next model we use is the GPT to be particularly GPT-4o. This is a pre-trained large language model with billions of parameters and only contain transformer decoder architecture. They are good at generate, and they have demonstrated that they are good chatbots. However, are they also good at prediction? This is one of our main interests in this project.
So I want to talk about how we do an improvement of our language model performance. So actually, you can see the block diagrams. So we use a multi-agent to do a prediction, which can increase the accuracy of one agent. So after that, we get a clean input training data, and then we first feed it to the doctor agent. So doctor agent will, based on the input column, to predict this result, CDR result. After that, he will, based on his result, to give a reasoning. So he will give each result and reasoning for each row, and he put all those results field to the critical evaluator. So at that time, critical evaluator will check the result and reasoning, and he will go to internet to find out some medical related article which can help to support or deny the reasoning of the doctor. So after that, he will put all those article and a summary of the work back to the doctor agent. So at that time, doctor agent can get a more article and a more summary for Alzheimer disease, and he can do a re-reasoning and also do a re-prediction to get a new result and send back. So we find out that will not increase a lot sometime, but indeed they will provide more resources for doctor agent to do a little more higher accuracy prediction. Yes, next please.
So this is the table of our accuracy table of all our models. You can see that from BERT to BioBERT and to GPTs and multi-agent GPTs, the accuracy is increasing, and we finally get a very high accuracy of above 19% in multi-agent GPT-4o with RAG. So to make the user that can use our model easier, we build a front-end website to all the users. Users can browse this service with their browser, and For example, they can upload an .csv file and to the server of our own, and this will trigger an Airflow procedure to pre-process and analyze and predict and generate the result. This result will send back to the user and displayed in their website. So here is the UI demo of our website, and I will show the actual use of them. So this is a raw website. We have not upload anything here. You can choose this data here and upload it. Since the data analyzed may takes a while, so we have shown the result here. So this is the this column is the raw CDR in the training data, and this is the predicted CDR that we model generate. We show the keywords in the column that may cause the Alzheimer disease. They are these are the keywords that related to this disease. And this is the pie chart showing the distribution of the predicted CDR. Also, this is the confusion matrix. As you can check that the performance is relatively good to a small data set. Yeah, so that's all for our presentation.
Thank you.